hydrochloric acid, and miscellaneous inorganic chemicals. First is the streaming out process for bromine manufacture. So the process involves a raw brine which is preheat at 90 degrees Celsius in an heat exchanger, giving off waste brine. Then it passes through a tunnel and goes down to a chlorinator tower. Then after partial chlorination, the brine flows out into a steaming out tower where steam is injected at the bottom and then the remaining chlorine is introduced. The halogen containing vapor is condensed and gravity separated in the gravity separator. And then the top water halogen layer is returned to the steaming out tower. And the crude solution, which is predominantly consists of bromine, is separated and purified. The bromine obtained after separation is not completely pure and contains chlorine. So the chlorine and most of the water are separated by distillation in the distilling column and then recycled to the steaming out tower. Then after condensation, the bromine will now go to the bromine fractionating column to further remove chlorine impurities and finally having bromine as the product. Second is figure 5.4 or the production of fluorocarbon. Anhydrous hydrogen fluoride and carbon tetrachloride are bubbled through molten aluminum antimony pentachloride catalyst in the reactivator. The gaseous mixture of fluorocarbons and non-reacted fluorocarbon is distilled using the distillating column to separate and recycle the chlorocarbon in the reaction. Then, it will go to the hydrogen chloride absorber, where hydrogen chloride is removed by water absorption. Then, traces of hydrogen chloride and chlorine are removed in a caustic soda scrubbers using sodium hydroxide and sulfuric acid. And now it will go to the compressor, then to the two distillating columns. Then it will be dried to produce dichloro-difluoromethane and then monofluoro-trichloromethane. Next is figure 5.5 or the refining of aluminum. So bauxite, a mineral containing 55% aluminum oxide and less than 7% silica, is crushed and wet ground to 100 mesh together with lime and soda ash. The finely divided bauxite is dissolved under pressure and heat in the Bayer digester with concentrated spent caustic soda solution and sufficient lime and soda ash. Then sodium aluminate is formed and the dissolved silica is precipitated as sodium aluminum silicate. The undissolved residue, also called as the red mud, is separated from the alumina solution by filtration and washing sent to recovery using thickeners and Kelly or drum filters. Then the filtered solution of sodium aluminate is hydrolyzed to precipitate aluminum hydroxide by cooling in the cooling tower and the cooling stock. The precipitate is filtered from the liquor and washed in the washing thickener. Then, the aluminum hydroxide is calcined by heating to 980 degrees Celsius in the rotary kiln and into the rotary container. The alumina is cooled to a rotary cooler and finally giving off alumina as the byproduct. Figure 5.6 shows the manufacture of aluminum sulfate using the Door process. In order to produce 1 ton of 17% aluminum sulfate or alum, the following materials and utilities are required. Bauxite 338 kilograms, sulfuric acid 572 kilograms, black ash 66 kilograms, flake glue 0.2 kilograms, coal or steams 380 kilograms, electricity 115 mJ, direct labor 1.6 working hours. Alums and aluminum sulfate are made from bauxite by the reaction of bauxite with sulfuric acid. The bauxite is ground until 80% passes 200 mesh and go to the bauxite feeder. Next, it is conveyed to storage bins. The reaction occurs in lead thin steel for torques, where the reactants are thoroughly mixed and treated with the aid of agitators and live stream. These reactors are operated in series. In the last reactor, barium sulfide is added in the form of black ash to reduce the ferric sulfate to ferrous state and to precipitate the iron. A mixture from the reactor is sent through a series of thickeners operated countercurrently, which remove undissolved matter and wash the waste. The clarified aluminum sulfate solution is concentrated in an open steam coil heated evaporator from 35 to 59 to 62 BE. Then it is poured into the flat cooling floor where it is cooled and solidified. The solid cake is broken and ground to size for shipping, grinding, and packing. Figure 5.7 shows the flow chart for the manufacture of sodium dichromate from chrome ore. In order to produce 1.1 sodium dichromate and 0.66 tons anhydrous sodium sulfate, the following materials and utilities are required. Chromite or 1.1 tons, limestone 1.65 tons, soda ash 0.88 tons, sulfuric acid 0.5 tons, fuel oil 0.52 tons, steam 3 tons, electricity 1,950 mJ, direct labor 13 working hours. So the starting material for the manufacture of sodium dichromate and other chromium compounds is chromite. The ore is ground to 200 mesh mixed with the ground lime and soda ash and roasted at approximately 1200 degrees Celsius in a strongly oxidizing atmosphere. The sintered mass is crushed and leached with hot water to separate the soluble sodium chromate, then filtered. The solution is treated with sulfuric acid to convert the chromate to dichromate, the resulting formation of sodium sulfate. Most of the sodium sulfate crystallizes from the boiling hot solution during acidification, and the other dumps out in the evaporators to form dichromate solution. From the evaporator, the hot saturated dichromate solution is fed into crystallizer, and then to the centrifuge, and then to the dryer. Lastly, it is now ready for packing and shipment of the byproducts, which is Na2, Cr2O2, 2H2O.